Hello everybody, welcome back to Beginning Algebra. Today we are in section 2.1 and we're going to be taking our first look at solving equations. So in this lesson we're talking about the addition property of equality. I'm going to show you what a linear equation is. I'm also going to show you how to use the addition property of equality to solve some simple linear equations. And then we're going to work on some equations that are just a teeny bit more complicated, so we'll simplify first and then solve by using the addition property of equality. Here we go. So first, let's define exactly what we mean by a linear equation. So remember that an equation is a statement that two algebraic expressions are equal. And a linear equation is an equation that can be written in this form: ax plus b equals c, where the a and the b and the c are all real numbers and the a can't be 0. Because if the a were 0, then a times x would be 0, and then you would no longer have an x term in your equation. So the thing that tells a linear equation apart from any other type of equation is that it has an x term. In other words, it doesn't have an x squared or a square root of x or any other form of the variable, just ordinary x. And so in a linear equation, the exponent of the variable must be 1. And whenever an exponent is a 1, we don't see it written. In a similar way that whenever a denominator is 1, we don't have to write it. Well, whenever the power is 1, we also don't have to write it. So this would be a times x to the first power, and that's what makes this a linear equation. So just for reference, here are a few examples of some linear equations. 4x plus 9 equals 0. Notice how this fits into that ax plus b equals c format, where the a number would be 4, and the b number would be 9, and the c number would be 0. Also, 2x minus 3 equals 5. And again, this fits into that ax plus b equals c format, because here we would have an a equal to 2, and this minus 3 could be written as plus negative 3. So b would be negative 3, and c would be 5. Also, x equals 7 is considered a linear equation. In this case, a would be 1 because we don't see a coefficient, therefore we know the coefficient is understood to be 1. B would be 0 because this could be thought of as x plus 0, and c would be 7. Now for some examples of nonlinear equations, we have x squared plus 2x equals 5. The thing that keeps this from being a linear equation is that our variable has an exponent on it, and it's not a 1. So this being x squared excludes this from being a linear equation. Same thing here, we have x to the third equals negative 1. This variable is being raised to the third power, and therefore this is not considered a linear equation. Here we have 1 over x equals 6. Now I know you're going to say to me that this x is to the first power, but this x is in the denominator, and you're going to find out later that that means when it's written in a standard form, its exponent is not really a positive 1. So this is not linear either. So now we know what makes an equation a linear equation. Let's talk a little bit about solutions. Remember that the solution of an equation is a number that makes the equation true when it replaces the variable. And we have previously been given equations and a possible solution, and we've been asked to determine if that number is a solution of the equation. Well, in this chapter, we're going to figure out how we can find the solutions ourselves. That's what this chapter is all about. So to solve an equation means to find all the numbers that make the equation true. In other words, to solve an equation means to isolate the variable on one side of the equal mark. So whenever the instructions ask you to solve an equation, they're asking you to find the value of the variable that makes the equation true. And fortunately, we don't have to do this by just looking at the equation and mentally figuring out the solution. there is a process that we'll go through to force the solution to show up in our work. And that's what I want to go through with you in this chapter. Now, because the expressions on both sides of an equal mark are the same, we can add the same value to both sides of the equation and the equation will still be true. So you can always think of the equal mark as the fulcrum in a balance scale. So for example, if we had the equation x minus 5 equals 2, then on the left side of the scale would be the x minus 5 and on the right side would be the 2. And just like a balance scale, if we add the same thing to both sides of the scale, then the scales will stay balanced, and that's what we want to do. But we want to add something that will isolate the x. So in other words, we want to eliminate the minus 5. Well, the opposite of minus 5 is plus 5. So if we add 5 to both sides of the equation like you see here, the scales stay balanced. And then on the left side, x minus 5 plus 5 would reduce to just plain x. And on the right side, you can see that 2 plus 5 would be 7. So after we add the same number to both sides, we can combine like terms on the left and then combine like terms on the right. Remember that the equal mark separates the two expressions from each other, so they're always treated separately. And the goal every single time is to isolate the variable. We want to get the variable by itself on one side of the equal mark. Also, remember that right now it's very important that you show what you're doing to both sides of the equation. You will eventually get to a level where you don't have to show what you're doing to both sides because it will just be understood. But right now, while we are beginning the process of learning to solve equations, make sure that you always show what you're doing to both sides of the equation when you show your work. Now remember, the goal is not to be able to just look at a problem and automatically know the answer. We always want you to go through the solving process. In this chapter, for us, the process is actually more important than the answer. Yes, the solution is important, and it's important to get that right. But when I grade a student's work in this chapter, I would much rather see the right process with the wrong answer than I would the wrong process with the right answer. I hope that makes sense to you, because if you have the process right and you're just making a little addition mistake, that can be fixed. But if you don't know the process, then you're going to eventually get to a place where you are stuck and you won't be able to move forward. So it's all about the process at this point. So here's example 1, and we want to solve the equation x minus 16 equals 7. In other words, we want to find the value of x that makes this equation true. And I don't want you to try to reason it out by just looking at the equation. I want you to solve it. So we are trying to isolate this x. That means we're trying to eliminate the minus 16. So the opposite of minus 16 is plus 16. So we're going to add 16 to both sides. See how I show what I'm doing to both sides. And now I'm going to combine like terms. X minus 16 plus 16 on the left side of the equal mark will simplify to just x. And on the right side of the equal mark, 7 plus 16 is 23. Now remember, you can always check your solution by substituting your solution in place of the variable, and we have done that before. If your solution is right, then both sides of the equal mark will have the same value. In other words, the equation will be true. But if your solution is wrong, then the two sides won't match and you should rework the problem. So let's check our solution here. Remember, this was our original equation, and our solution that we found was 23. So we are going to replace the x with 23. And notice that I put a little question mark over the equal mark because we're not saying that the left side equals 7 here. We're asking, does the left side equal 7? So the question mark is just there to remind us that this is something we're trying to verify. Okay, so when we do this subtraction, 23 minus 16 really is 7. So now we have a statement that says 7 equals 7, which is true. And this is telling us that our solution of 23 was the correct solution. Okay, now let's talk about how to write this answer in MyLabs Plus. In MyLabs Plus, you'll notice that they give you something like this. It will always say the solution set is, and it will have these curly braces on the screen with a box in here for you to type your answer in. All you need to put in between the braces here is your solution itself. All you need to put is just 23. What students always think they're supposed to do is put x equals 23. But the reason you don't want to do that is because we're using set notation here. These curly braces mean everything inside the braces is a solution of the equation. So if you put an x in there, you're saying that x is the solution, but it's not. The solution is 23. So all you type inside the braces is just the number. Now here's one you can try by yourself, so pause the video and try it on your own. And now I'm going to go through this with you. Here we have x minus 25 equals negative 18. So we want to isolate the x, and that means we want to eliminate the minus 25. So the opposite of minus 25 is plus 25. So you want to show that you're adding 25 to both sides. Remember those balance scales and how you always do the same thing to both sides of the equal mark so you can keep the scales balanced. Okay, now let's sum up what's on each side. The minus 25 and the plus 25 are going to add up to 0. So x minus 25 plus 25 just adds up to plain old x. And then on the right side, negative 18 plus 25 adds up to positive 7. And so our solution is that x equals 7. Now we need to check our solution. This is just a really good habit to get into. Even if you don't write it down every time, you at least should make a habit of mentally putting your answer back into the equation and seeing if it makes sense. So our original equation was x minus 25 equals negative 18. I'm going to put the 7 in place of the x. So we'll have 7 minus 25 equals negative 18. And there's the question mark because we're trying to decide if this is true or not. So we need to work out what we have on the left side. Now 7 minus 25 could be restated as 7 plus negative 25 if you need to do that. And then you can see that when we subtract and use the sign of the larger number, the left side gives us negative 18 and the right side gives us negative 18. And so now we have a true statement, and this is verifying for us that our solution was correct. So when you get to MyLabs Plus and you want to put the answer in, remember it will say the solution set is, and it'll give you the curly braces, and all you put in the braces is your solution, which is 7. Now, because all subtraction can be rewritten in addition form, we can not only add the same thing to both sides, but we can also subtract the same number from both sides of an equation. So let's look at example 3. Here we have negative 7 equals x plus 22. So again, the goal is always to isolate the variable, and therefore we want to eliminate the plus 22. So the opposite of plus 22 is minus 22. I can put minus 22 on the right side, but to keep things balanced, I have to also put minus 22 on the left side. So notice how we're always doing the same thing to both sides, and the way we decide what to do to both sides is by figuring out what it takes to isolate the variable. So now let's add up what we have on each side. On the left side, we have negative 7 plus negative 22. So the signs are the same. We add the numbers and keep their sign. That's going to give us negative 29. And on the right side, x plus 22 minus 22 is going to add up to x. So our solution is x equals negative 29. Now let's check our solution. So we'll take our original equation and put negative 29 in the place of x. And so now we want to evaluate what we have on the right side. Negative 29 plus 22 is equal to negative 7. So this gives us a true equation. And now we know that negative 29 is the correct solution. So in the curly braces in MyLabs Plus, you would just put negative 29. Now, so far we've gotten the right answer on every equation we've solved, but suppose that we made a mistake when we solved the last equation, and suppose we thought that the solution was x equals negative 15. Let's check that solution and see what happens. When we substitute negative 15 in place of x, we'll get negative 7 equals negative 15 plus 22. Now when you add up what you have on the right side, the larger number is positive. So this answer is going to come out positive 7 on the right side. That's going to give us an equation that says negative 7 on the left equals positive 7 on the right. And this is not true. Negative 7 is not equal to positive 7, so this is false. And this is just telling us that the solution we found was not correct. So if you come up on this situation, you might first just make sure that you're adding correctly. But if you really did add correctly and your statement is just false, then what you need to do is go back and start the problem over and try again. Now let's add another wrinkle. Just as we can add and subtract constants on both sides of an equation, we can also add and subtract variable terms. Remember, variable terms just represent unknown numbers. So, of course, we can add and subtract them to both sides of an equation. Here is an example for us. This says solve 6x minus 8 equals 7x. So I have an x term on the left and an x term on the right. And we need to get all the x's together because remember we're trying to isolate x on one side of the equal mark. So notice that I have a variable and a constant here on the left. What I would like to do is make this variable term disappear from the left side so that the only variable term I have is on the right. So what we can do to eliminate this plus 6x that we have here, positive 6x, what we can do is subtract 6x from both sides. This is okay to do because I'm doing the same thing to both sides. Notice I'm putting minus 6x on both sides. So now combining like terms on the left, the 6x and the minus 6x add up to 0x, which is just 0. So 6x minus 8 gives us negative 8 on the left side. And on the right side, 7x minus 6x gives us positive 1x. And we know that whenever the coefficient is a 1, that we don't have to write it. It can just be an understood 1. So what we have here is that x equals negative 8. Now, to make sure that we did everything right, we need to check our solution. So our original equation was 6x minus 8 equals 7x. I'm going to substitute negative 8 in the place of x. So we'll have 6 times negative 8 minus 8 equals 7 times negative 8. And I put the little question mark here to remind us that we are trying to verify whether this is true. So now 6 times negative 8 is negative 48. And then we have minus 8. And the right side would be 7 times negative 8, so that's negative 56. Okay, let's add up what we have here on the left side. Negative 48 plus negative 8 would be negative 56, and that matches what we have on the right. And that means we have a true statement here, so negative 8 is the correct solution. So in MyLabs Plus, we would just put negative 8 inside the braces. Now, here in example 5, we have an equation with fractional coefficients. That is, we have coefficients that are fractions. And that's fine. They behave just like any other coefficients that you might have. So we're going to solve this using just the addition property of equality. That is, we're going to do it the same way we've been doing it. But I do want you to know that there is a better way to do this, and I'll show you that in the next section when you're ready for it. But for right now, let's look at 3/5 k plus 15 equals 8/5 k. Now, this is very similar to the last example in that we need to eliminate this k term so that our only k term is this one on the right side. So let's just start by subtracting 3/5 k from both sides. So I've written minus 3/5 k on both sides. Now, positive 3/5 k minus 3/5 k, of course, is going to add up to 0. And so 3/5 k minus 3/5 k plus 15 adds up to 15. Now on the right side we have 8/5 k minus 3/5 k, and that gives us 5/5 k. Now you know 5/5 reduces to 1. So what we have here is that 15 equals 1k, or we could just write 15 equals k. So that's our solution. And now what we should do is check it. And I've noticed that a lot of times students shy away from checking solutions on equations with fractional coefficients, but you don't really need to do that because you'll see that the fractions are not going to bother us at all. I'm going to show you how to handle this. So the first thing we want to do is copy our equation over but put the 15 in place of the variable. So we'll have 3/5 times 15 plus 15 equals 8/5 times 15 with the question mark to show that we're trying to verify that this is true. Now, instead of multiplying tops together, what you need to do is think about reducing first. So 15 divided by 5 will reduce to 3. And likewise over here on the right side, 15 divided by 5 again will reduce to 3. So what we're going to have here is this 3 times the 3 that we got when we simplified plus 15 equals this 8 times the 3 that we got when we simplified. So now what we have is something much simpler. So 3 times 3 is 9. On the right side, 8 times 3 is 24. And so now all we're trying to do is verify that 9 plus 15 equals 24, and we know that's true. So we just verified that 15 is the correct solution. So in MyLabs Plus, we would put 15 inside the braces. Now, if you have an equation that has both variable terms and constant terms on both sides of the equal mark, then sometimes it's not as easy for students to tell which side should belong to the variable term and which side should be the constant. So the easiest thing to do is to figure out which of your variable terms is smaller and add that smaller variable term to both sides. Let me show you what I mean. So here is example 6. We have 8 minus 6p equals negative 7p plus 5. So can you tell when you look at this that it's not as clear as it was before which side should be the variable side and which side should be the constant side? So in a case like this where I have a constant and a variable on the left and also a constant and a variable on the right, what I do is I look at the variable terms and I say which of these coefficients is smaller, negative 6 or negative 7? Well, negative 7 is less than negative 6 because think about it. You'd rather be $6 in debt than $7 in debt. So clearly negative 6 is a little bigger than negative 7. All right, so let's add 7p to both sides. So I'm going to add 7p to the right and 7p to the left. And now let's combine like terms on the left side. 8 minus 6p plus 7p is going to add up to 8 plus 1p. On the right side, negative 7p plus 5 plus 7p is going to add up to just 5. Now, in this case, we still have not found the solution yet because the variable is not yet isolated. So now we can see that we need to eliminate the positive 8. So we will do that by putting minus 8 on both sides and combining like terms again. So let's say positive 8 plus p minus 8 is going to add up to just p. And on the right side, 5 minus 8 is going to add up to negative 3. So the solution we came up with is negative 3. Now let's check our work by replacing p with negative 3 in the original equation. So we'll have 8 minus 6 times negative 3 equals negative 7 times negative 3 plus 5. So we use order of operations to simplify the expressions on each side, and although we treat them separately, you can go ahead and do them both at the same time. So let's go ahead and do both of these multiplications. On the left side we have 8 minus 6 times negative 3. So we know that negative times negative is going to make positive, and we know that 6 times 3 is 18. Over on the right side we have negative 7 times negative 3, and that's positive 21. And then we have plus 5. So now we just need to verify that 8 plus 18 is the same as 21 plus 5. Of course, 8 plus 18 is 26. On the right side, 21 plus 5 is also 26, so we know our solution is true, and we can say that the solution to this equation is -3. Now here are a couple of equations that you can pause the video and try on your own, and I very much encourage you to do that, and then we'll go through them together. Okay, so here we go. We'll look at 2/3 m minus 4 equals 5/3 m. All we need to do to eliminate this m term is subtract 2/3 m from both sides. So that's going to give us on the left 2/3 m minus 4 minus 2/3 m. The m terms will add up to 0 and the left side will be -4. On the right side, 5/3 m minus 2/3 m is going to be 3/3 m, which reduces to 1 m. So now we have m equals -4. You can check this very easily by putting -4 in place of the variable. And now in this case, notice that we can't do the simplifying we did on the previous equation with fractions, but it won't be very difficult at all to get this checked. 2 times -4 is -8, so this fraction is going to be -8/3. Then we have minus 4. This fraction is going to be 5/3 times -4, which is -20/3. Now we need a common denominator, so I'll multiply this whole number by 3/3. That will give us -12/3 for that term. And now we have -8/3 minus 12/3 equals -20/3. And you know that -8 plus -12 would be -20. And so we've got this verified now is true, and we can say that the solution set here would be -4. On part B, notice we have variable terms on both sides of the equal mark and constants on both sides of the equal mark. So the best way to solve this equation in the least number of steps is to look at our variable terms and decide which one has a smaller coefficient. We have a -2 and a -1. So -2 is a little bit smaller than -1, so I'm going to eliminate this -2a term. So I'm going to start by adding 2a to both sides of the equal mark. And now let's combine like terms on the left side. 10 minus 1a plus 2a is going to add up to 10 plus 1a. On the right side, -2a plus 2a plus 9 adds up to just 9. Now we continue trying to isolate the variable, so we need to eliminate the positive 10. So I'm going to say minus 10 on both sides, and that's going to give us a equals 9 minus 10, which is -1. Now you can plug the -1 back into the original equation. 10 minus -1 equals -2 times -1 plus 9. Just use order of operations to verify that the two sides have the same value. Minus -1 makes plus 1 here, so on the left side we have 10 plus 1. -2 times -1 makes positive 2, so on the right side we have 2 plus 9. Now we know that 10 plus 1 is 11, 2 plus 9 is also 11, and so this solution is verified as correct, and our solution here is -1. Now very often when you're solving equations, there's more than one sequence of steps that you can use to get the right solution, but each equation only has one solution set, so no matter which order your steps are in, your solution will be the same either way. That's why if you're working with a friend, they may have one set of steps, you might have a different set of steps, but you both have to get the same answer or somebody has made a mistake. So let's look at example 7 together. Here we have 3w minus 12 plus w plus 2 equals 5 plus 3w minus 15. Now before you start adding the same thing to both sides of the equal mark, the best way to solve this with the least number of steps is to first combine all your like terms on the left and then combine all your like terms on the right. Look just at the left side of the equal mark for a second. We have 3w and 1w. Together, those will make 4w. And then we have -12 and +2. Together, those add up to negative 10. So you could either write plus negative 10 or you could just write minus 10. On the right side, we have 5 and minus 15. So 5 plus negative 15 is going to add up to negative 10. And then don't forget we also have our 3w. So now this is the simplified equation we want to solve. This is one of those where we have variables on both sides of the equal mark and we also have constants on both sides of the equal mark. So again, the best strategy to isolate the variable is to figure out which variable term has the smaller coefficient, that would be the 3w in this case, and then eliminate that variable term. So I'm going to put minus 3w on both sides of the equal mark. Now 4w minus 3w is going to be 1w. Then we also have our minus 10. Over here on the right we have our negative 10, and the w's will add up to 0. So the right side is just negative 10. Okay, now we need to continue trying to isolate the variable. So we will add 10 to both sides. Let's add 10 here, and then we will have on the left side just w, and on the right side negative 10 plus 10 adds up to 0. So the solution here is 0, and we could verify that. A lot of times I'm not sure why it bothers students if they get an answer of 0. It's like they think that can't be an answer or there's something wrong here. But no, it's entirely normal for the solution to be 0. Let's just check it and find out if it's right. So we will plug 0 in everywhere we had a w. We'll have 3 times 0 minus 12 plus 0 plus 2. And we want to find out if that's equal to 5 plus 3 times 0 minus 15. Now we can go ahead and do the multiplication by 0 here. So that will give us 0 minus 12 plus 0 plus 2, I did not record the second 0, equals 5 plus 0 minus 15. So on the left side we have here negative 12 plus 2, that's going to add up to negative 10. On the right side we have 5 minus 15, that's also going to add up to negative 10. And so we see that this solution does check. And therefore in my math lab we would put 0 inside the curly braces. Now if you are one of our online students and you take your quiz online, then when you show your work, remember checking is not the same as solving. You must show the solving steps on our quiz to receive credit, and you only have to type out the checking step if the instructions say that you must check your solution. Now you should always check your work, but you don't always have to type it out. Only type it out if the instructions say to check. But remember that if you don't show the solving step, then checking your work doesn't get you any credit. Okay, here is a practice example, kind of like the last one we did. If you would like to try this one on your own, I think that's a great idea. But now I'm going to go through it with you. So here we have 4x plus 6 plus 2x minus 3 equals 9 plus 5x minus 4. So our first thing is that we need to combine all the like terms on the left side, and we need to combine all the like terms on the right side. So looking here, we have 4x and 2x. Together they make 6x. Then we have 6 and negative 3. Together they make positive 3. So the left side simplifies to 6x plus 3. On the right side, we have these two constants, 9 and minus 4. Together they make 5. So the right side simplifies to 5 plus 5x. Now we have one of those equations where we have variable terms on both sides of the equal mark, and we have constant terms on both sides. So in this situation, what we want to do is look for the variable term with the smaller coefficient and eliminate that. So let's say minus 5x on both sides. And now on the left side, the 6x minus 5x will add up to 1x, and then we have our plus 3 here. On the right side, we have 5 plus 5x minus 5x, so the x terms add up to 0, and we just have 5 on the right side. So now continuing to isolate the variable, we can see we need to get rid of this constant term. So we'll put minus 3 on both sides of the equal mark, and that's going to give us on the left x plus 3 minus 3, which adds up to x, and 5 minus 3, which adds up to 2. So our solution is 2. Now let's check this. We'll put 2 in place of the variable, so we'll have 4 times 2 plus 6 plus 2 times 2 minus 3 equals 9 plus 5 times 2 minus 4. Now let's go through and do all the multiplication. 4 times 2 would be 8 plus 6. 2 times 2 would be 4, so we have plus 4 and then minus 3. On the right side we have 9. 5 times 2 makes 10, and then we have minus 4. Now let's add everything up and see if the two sides match. 8 plus 6 is 14. 14 plus 4 is 18, and 18 minus 3 is 15. On the right side, 9 plus 10 is 19. 19 minus 4 is also 15. So this solution is verified, and we can say that the solution set is 2. Now here's one where we have a couple of pairs of parentheses. So we need to eliminate the parentheses before we start trying to solve. And of course we will do that with the distributive property. So here I'm going to multiply 3 times each of these terms, and then I'm going to distribute the minus sign into this set of parentheses. So 3 times 2 is going to give us 6. 3 times positive 5x is going to give us plus 15x. Now remember that distributing a minus just changes all of the signs, so that's going to give us minus 1 and minus 14x, and that's equal to 6. Okay, now over on the left side, combining like terms, I have a 15x and a minus 14x. Together those add up to positive 1x. And then we have a 6 and a minus 1. Together those add up to positive 5. And the right side is still just 6. Now, continuing to isolate the variable, we want to get rid of the plus 5, so we'll put minus 5 on each side. On the left side, that's going to simplify and give us x. On the right side, 6 minus 5 is 1. So we think our solution is 1. Let's plug 1 into the equation and see if it works out correctly. So I'm just going to copy this over, putting 1 in place of the x's. So that's going to be 3 times 2 plus 5 times 1 minus parentheses 1 plus 14 times 1 equals 6. Okay, now remember, we just use order of operations on the left side to simplify everything. Now we may as well go ahead and simplify the parentheses both at the same time, since they both seem to consist of a multiplication and an addition. Let's go ahead and do both multiplications on this first step. 5 times 1 is 5, and 14 times 1 is 14. And then inside the parentheses we can do the addition. Here 2 plus 5 is 7, and here 1 plus 14 is 15. So that's going to give us 3 times 7 minus 15. And now this multiplication would give us 3 times 7 is 21. So we have 21 minus 15 equals 6. And of course we know that that is true. And so now we know for sure that the solution is 1. Now here is one with parentheses for you to try on your own. So I hope that you will pause the video and try this yourself. And now I'm going to go through it with you. First, let's distribute the 2. So we'll have 2 times 5 here is 10. 2 times 2m is 4m. And now distributing the minus 3, we'll have negative 3 times m is minus 3m. And negative 3 times negative 4 is positive 12. And that's got to equal 29. Now look at the left side. We have a couple of pairs of like terms. So 10 plus 12 adds up to 22. And 4m minus 3m adds up to positive 1m. And on the right side we still have just 29. So now we want to isolate m. So we will subtract 22 from both sides. And that's going to give us on the left just m, and on the right positive 7. Now let's check our solution. So we'll put 7 in place of the m everywhere that the m occurs. Let's go ahead first and do this multiplication. 2 times 7 is 14. And so now let's see what we have. 5 plus 14 is 19, and 7 minus 4 is 3. So that's going to give us 2 times 19 minus 3 times 3. Well, 2 times 19 is 38, and 3 times 3 is 9. So that's going to give us 38 minus 9. And we do know that 38 minus 9 is equal to 29. So we have verified that the equation is true, and our solution is 7.